My only witnesses are shadows on my screen. I recall those good old days, busy rushing through the town, breaking bread with a good old friend, laughing over a glass of wine. Shadows fly, days go by. Sometimes I lose the will to try. Shadows lurk from the past. How much longer is gone and lost? Just to see you once more in this life, face to face. I can't explain why I need you here in my space, trapped in these four walls. I hear loudly, silent scream. My only witnesses are shadows on my screen. Shadows fly, days go by. Sometimes I lose the will to try. Shadows lurk from the past. How much longer is gone and lost? Every day, work to play. I sit in the same old chair, dreaming of sweet rush hour days. I commute to feed my way, just to see you once more in this life, face to face. I can't explain why I need you here in my space, trapped in these four walls. I hear loudly, silent scream. My only witnesses are shadows on my screen, trapped in these four walls. I hear loudly, silent scream. My only witnesses are shadows on my screen.
Hello and welcome to the second day of the MSR AI and Gaming Research Summit. My name is Chris Bishop. I'm a technical fellow at Microsoft and I'm also the laboratory director of Microsoft Research here in Cambridge, UK. I actually have a background in theoretical physics, but something like 30 years ago, I got excited about the then new field of neural networks, and I've been in the field of machine learning ever since. And I actually joined Microsoft nearly 25 years ago. So it's a tremendous pleasure to have so many people join this event. We have people from Xbox, people from Microsoft Research, from the academic world, from the games industry, and many other partners. So a very warm welcome to all of you. Now, the music that you've just been listening to was in fact generated by AI in cooperation with a human composer and a human vocalist. So a big thank you to Maya Ackerman, who of course spoke yesterday, and Igor Fakovsky for providing this. It's a really nice example, I think, of AI in partnership with humans. The lyrics were generated by AI, the music was composed by Igor, and the vocals were by Maya. So thank you for that. So Microsoft Research is absolutely delighted to bring you all together today to share ideas and to discuss how AI and machine learning is really transforming the gaming landscape. Gaming has this wonderful ability to connect players across the world thoughtfully and inclusively. And I think that's especially important right now, of course, in the middle of a pandemic with all of these widespread lockdowns and real restrictions on movements. So today we have very thoughtful talks and discussions to look forward to on topics such as responsible gaming, understanding players, and AI agents. And then finally, to round out the day, we have what should be a very interesting fireside chat between Peter Lee, who is Corporate Vice President for Research and Incubation at Microsoft, and Kareem Chowdhury, who's CVP Corporate Vice President for Gaming Cloud at Microsoft. But first of all, to kick things off, I'd like to hand over to Mikhail Jacob. Mikhail is a researcher in game intelligence here in Microsoft Research in Cambridge. And so to get things going, it's over to you, Mikhail.
Thanks for the fantastic welcome, Chris. Hello, everyone. Welcome to this academic research plenary. Thank you all for participating in the AI and Gaming Research Summit today from all over the world. Before we get started officially, I just wanted to remind everyone that we're splitting off into two parallel tracks today, immediately after this session. In the first part, we'll have the AI agents and responsible gaming tracks, and in the second part, we'll have the understanding players and responsible gaming tracks. You should have received links to all these sessions through an invite, but we'll also put up the links at the end for your convenience. You can find the abstracts for all the talks in each track on the Summit website and choose your own adventure today. And if you're wondering how to choose between parallel tracks with all the amazing speakers we have for you today, don't worry. We'll release recordings of all the talks soon, and you should be able to see all the exciting talks you had to miss within about a week or so. We will have a live Q&A at the end of the session. Please drop your questions during the talk into the moderated Q&A as you think of them, and upvote any you'd especially like to hear answered live by our speaker. Great. Let's get started with the session then. My name is Mikhail Jacob. Thank you so much for having me here to chair this plenary. I'm a postdoctoral researcher with Microsoft Research in Cambridge. In my current role, I'm studying what tools and workflows will help game designers and developers actually use some of the fantastic AI techniques like reinforcement learning and imitation learning in order to make them even more amazing games. Before that, I got my PhD from Georgia Tech in 2019, working on computationally creative systems that can create and improvise with people. It is my great honor to introduce Dr. Mark Rydell as our academic research plenary speaker today. I have known Mark for about a decade, working with him through my master's and PhD at Georgia Tech. He was even the one grilling me at my PhD defense. Mark is an associate professor at Georgia Tech's School of Interactive Computing and the director of the Entertainment Intelligence Lab. Mark is an internationally renowned expert in computational creativity, whose research has long tackled problems at the broad intersection of artificial intelligence, virtual worlds, and storytelling. He even used to teach a class called AI Storytelling in Virtual Worlds that I took myself as a baby master student about a decade ago. Mark's research is focused on automated story generation, interactive narrative, and adaptive computer games, where he and his group have made many foundational contributions. His work has also made contributions to virtual cinematography in 3D virtual worlds, player modeling, procedural content generation, computational creativity, intelligent virtual characters, and many, many other areas. Mark is also one of the original advocates for human-centered AI. His work on AI addresses these needs and capabilities that are incredibly human, like understanding and explaining the world through narrative, and being creative in novel situations. He earned his PhD in 2004 from North Carolina State University and was a research scientist at the University of Southern California at the Institute for Creative Technologies after that. Mark has been awarded a DARPA Young Faculty Award and an NSF Career Award. His work has also been supported by the NSF, DARPA, Google, and Disney. Thank you so much for speaking to us today, Mark. Please take it away.
Thanks, Mikhail. It's been great to see you again. I remember the days when you were TA in my storytelling class, and I think you did more to teach the students than I did that year. So you've always been a great compatriot in the pursuit of fun and interesting artificial intelligence. So I'm super pleased to be here. I wish we were here in person, but that's not going to happen. And so I'm coming here from Georgia Tech. So I'm a professor at Georgia Tech, and I work on artificial intelligence. I like to think that I work on the fundamental issues surrounding artificial intelligence, but I like to do it through a lens of storytelling, creativity, and computer games, because we can make hard problems interesting and applicable to the real world. So I'm going to talk today about computational creativity, what that means, and why it's such a great match for artificial intelligence and computer games. If you were at the summit yesterday, there are tracks on computational creativity. We got to see some great and amazing things by some renowned researchers. I'm not going to reference that. This is kind of a capstone to that track, but also hopefully something that will be of a interest and excitement to a more broad audience. So with that, I'm going to talk about computational creativity and just a little bit about myself. So once upon a time, I did my thesis and I built a story generator. And for some strange reason, they gave me a PhD for that. And I still haven't figured out why, but that is what it is. So I started down this pursuit of computational creativity. And what I really want to do is I want to talk about why we should care about computational creativity and games and artificial intelligence and how these three things come together in really fascinating, interesting sorts of ways that allow us to work on hard problems. And I've been working in this area of computational creativity for a long time. So as a PhD student, I built something called a story generator that was able to put out text that we might read as a story. And since then, I've worked on many different story generation systems, but I've also gotten into graphics and computer games through cinematography, through procedural generation of levels for computer games, and so on and so forth. And through all this time, I've been working on artificial intelligence algorithms where the outputs are things that humans get to relate to and consume and maybe someday even hopefully enjoy. So this is broadly in the area of computational creativity, an area that has been gaining lots and lots of attraction, especially in recent times with generative adversarial networks and neural networks of a variety of sorts. So I'm showing some examples of generative projects using neural networks. These are visual because slides are easy to show pictures, but of course you can also think of music, and we've seen poetry and stories and many other things like this. And of course, this progress in computational creativity has not ceased. So even just in the last few weeks, OpenAI came out with their DALL-E system, which is able to do interesting blends of things and generate pictures that we've never seen before. So for example, trying to put together a picture of a giraffe turtle hybrid, right? So we are we're seeing in the visual domains, but also all the domains, lots of activity in terms of computational creativity. And through all this time and working in generative systems and seeing all these amazing things happening in the world, I've often wondered, what actually is creativity? When we say we're building creative systems, what is creativity and what does it mean to build a system that can be creative? And I'm now about to give you my answer to this question. What is creativity? Okay. I have no idea. In the 15 years I've been working on this, I could not tell you what it means to be creative or what it means to build a creative system. But I can tell you from my experiences that there are a few things that we do know need to be thrown into the mix, to be thrown into the pot to build a system that is called computational creativity. And I'll just kind of go through some of the things. This is not at all an exhaustive sort of thing. But some of the things that we might think about is novelty, expectation, learning, and intention. And I'll tell you a little bit about what I think these things mean. And the easiest one I think to get a start on is novelty. Novelty means producing something that hasn't been seen before. Either the AI system has never produced something exactly like it before, or no one else in the real world has ever seen a thing like this. There's not much to say about novelty. We can achieve novelty very easily through randomness, for example. But novelty isn't the end of the story for creativity, because if we have too much randomness, then things become noise, things become gibberish. So we balance novelty with something called expectation. And expectation is semantic understanding. So whether someone can still make sense or derive understanding from something that has been created. So do the things that get created by an algorithm share references to things that we as humans understand, these semantic references, relationships. And we can kind of give an example with this DALL-E system. We can say, well, one of the things that it's been shown to do is to create illustrations of baby radishes and tutus walking a dog. And what you can see in all these images are, we get a sense of radishes, we get a sense of tutus, we get a sense of dogs. Dogs are on leashes, that implies walking. The tutus are always approximately in about the same place you'd expect a waist. While radishes don't have waists, we kind of understand that this pink ring around the lower third of a body is probably going to be a tutu. And there's also some mistakes. So the leash is often attached to the clothing and not to an arm. So it's not perfect by any means, but it is tapping something that we understand. The relationships between the things in the images are not completely random, yet there's enough randomness that we see lots of variety, and that's particularly great. That's not all there is. More advanced art challenges our mental models, challenges our expectations, forces us to think harder and deeper about what we're seeing. Now, moving on from expectation, we can also talk about the role of learning and creativity. Now, for a long time, creativity and learning were not put together, but I think they're actually very important. So in learning, when humans express creativity, when we talk about learning, we're talking about skill. So what is it about doing art or music that requires skill? Skill is something that we learn because different types of art, different types of expression have, again, expectations, but also genre, right? There are certain forms and structures that we allow in certain types of music, for example, that we don't allow in other types of music. And the way that we learn creativity, it's not that we learn to be creative, we learn skill, right? And the first stage is imitation. So we learn to imitate the art we like. Once we get good at imitation, we start to explore beyond what we've seen in the past and express ourselves in new ways, branching off progressively further and further from the things that we have seen other people do. And then eventually we get to the point where we can say, I'm actually going to challenge people's expectations. This is advanced. Not everyone ever gets to this, right? This is like, I'm going to create a new genre of art, for example. But this has interesting parallels as well to artificial intelligence. So currently, a lot of what we see, especially in the visual arts, is about neural networks minimizing a delta from some sort of exemplar. So you give me a bunch of examples, I will try to recreate those examples. I won't do exactly what you've done because the function that I'm trying to learn is too complicated, but I'll get close. And then in recent years, we've started to see a little bit more thinking about what it means to create with neural networks, right? We start to say, well, try to get close to exemplars, but also make sure we're thinking about novelty and semantic goals and other attributes that we want to see in our art. And then phase 3 is something I think we just do not know how to do with artificial intelligence, although that's very exciting. Now, learning brought up the notion of intentional deviation. So let's talk a little bit about intentionality. What does intentionality mean in creativity? It means goal-seeking behavior, right? So I might want to achieve a particular goal. This goal might be very direct, like I need to get from here to the mall in 15 minutes. So that's the sort of creativity that Siri can do. I think we don't often like to think about Siri as being creative, but it does in fact create things. Given a goal, it will try to achieve those goals. Or how do I get a toy out from underneath my couch or something like that. Sometimes they're very explicit goals. Sometimes they're very abstract goals. I want someone to feel emotion. I want them to feel happiness or sadness. And it's not always clear how to express that goal, but I know that I have to place elements into my art. And how I achieve those things will get me closer or further away from the goal. Moving on from that, we can say creative expression often involves more than just goal-seeking behavior. We might want to also achieve the goal, but in unexpected, but still understandable ways. So this is intentionality, cross novelty, cross expectations. And then at the highest level, we know that humans often change their goals when they do art. And that is, again, something that we don't know how to do in artificial intelligence. And it's something that we can strive for as we think about computational creative systems. Okay, now kind of having talked about creativity in general, let's talk more specifically about how we create systems or how we build systems that create. Right, so we want to build systems that are computational creativity systems. They're going to take inputs. They're going to produce novel outputs that are understandable, that are intentional, may or may not involve machine learning. We saw a bunch of great examples from this the other day in the computational creativity sessions. Right, and I'm going to talk a little bit now about some of my own work in these areas and kind of bring this to games. Now, we've been talking about the abstract. Let's talk about things much more specific in terms of games. And specifically, I'm going to talk about a certain type of game called interactive text games. And these are games that don't have graphics, they just have text, and we interact by reading and we interact with the game by writing simple phrases. And we'll get into what these games are, and I'll tell you a little bit about why I think these are really interesting to pursue computational creativity within. But let's step back a little bit and say, why should we even think about computational creativity in computer games? What is it about computer games that make it really easy and interesting to think about creative systems? Because I think it's not so obvious, right? Most of our examples have been in the visual domain and in the art and music domain. But I think computer games are actually really good for computational creativity. And one is because computer games are dynamic and interactive systems. So, outside of, visual art is great, right? The work that's being done in visual art is great, but it's not clear what happens when humans look at art, right? In computer games, people must actually interact with the system must respond to user inputs, and those responses must be meaningful, interesting, and relevant to it. So we actually get to know a little bit more about what people do in games because we see them actually acting out, driving little characters around in games, right? Kind of gives us a lens into what they're thinking, how they're solving problems, so on and so forth. And of course, when the game responds to the player, it's got to do so with rich semantics. The things that we see and interact with in computer games have to have meaning to the player, right? We're not just moving around random images on top of random images, right? The things we expect doors to respond in ways that doors respond, and so on and so forth, right? So the elements that we interact with in games have to have meaning, because otherwise it's hard to see how we can make progress through games. So this means that we have to build a space. The space, now the creative things that we're creating are now spaces, and they have to support the human player. It means that when we create, when our algorithms create, we have to at least have some sort of notion of a human player, of a human mind coming to us and supporting that human mind, right? And that's something that maybe is a little bit more abstract when we think about other types of domains. And I think as a scientist, I appreciate this. Evaluation might actually be easier. Why should evaluation be easier in computer games? Well, if I generate a computer game or aspects of a computer game and a player interacts with those things, the player is either able to make progress through the game or they're not able to make progress, right? So we can see what they do in response to the things that appear in the game to them. We have a much more immediate understanding of this interaction, this engagement between the player and the created artifact. And this is a particularly nice thing to have that it's a little bit harder to get in other forms of art. And then finally, games are just really complicated things, so we don't have to do everything at once. We can break it down into little bits. We can look at the mechanics of the games. We can look at the content or the levels or the art or the stories and quests. We can kind of pick and choose different parts of the game to work on at various different times to ask different research questions. Okay, and now computational creativity and games have gone together for a long time. This is often referred to as procedural content generation. We see this both in research, but we also see this out in the real world. So games such as No Man's Sky, which was kind of a big kind of social phenomenon a few years ago, where they generated millions and billions of different possible planets, and you get to fly around in spaceships and visit all these planets and experience strange alien landscapes and strange alien life forms. That was a more recent sort of thing, but actually procedural content generation has a long history in computer games. Going back 20 years ago, 10, 20 years ago, games like Star Trek Online generated different interstellar phenomenon for you to interact with. And then even going back to my childhood in the earliest days of computer graphics, things like Elder Scrolls 2 would have procedurally generated forests and villages that you can interact with. This allowed people to make very, very large involved worlds for the human to explore. And the trick was making sure that people actually understood that when you're in a village, it actually looks like a village, right? So there's this notion of semantics being very important. Even from the early days of computers, creativity was always kind of part of computer games. Now in research, we do other things as well, right? We look at trying to procedurally generate Super Mario Brother worlds or other sorts of things. This is a little screenshot of the work by someone that was on my team for a while, Matthew Gusdile. He did a great job moderating the sessions yesterday, but you probably didn't get a good chance to see all of his cool work. So go check that out. I encourage you. But I'm going to not work in graphical games for a while. At least the next little bit of my talk is not going to be about graphical games. They're going to be these interactive text games. And why should I work in text games when I have all these other game genres Mario and all these other things to work with. And one of the reasons why is I don't have to worry about graphics. Now, this is probably heresy because I'm in a games symposium, a games summit, and I'm talking about things that are not wanting to work with graphic. I'll tell you why I don't want to work with graphics, because the human mind, the human imagination is the most powerful graphics processor in the world. So if I give you a game that's a text game, you're going to look at something a little bit like this. You're going to see text, and the text is describing to what's happening in the world around you. So I only need to tell you that you're in a forest path and there's a winding path through a dimly lit forest. And suddenly, even just through a small number, a few dozen words, I can convey kind of a rich, semantically engaging environment. We understand what it means to be in a forest. We understand low branches and paths and dimly lit and all these sorts of things. So with just a few words, I can convey a very complicated, rich situation. So text adventure games, if you haven't played them, are all about reading and writing. So you will get a description of the world that you're in that looks like this. You then have the opportunity to type in words to do what you want to do, and the world responds to you. So I climbed the tree. I'm now up a tree. I'm about 10 feet up in the ground. I'm in some large branches. I see a nest. The nest has an egg, so on and so forth, right? Again, a rich semantic space is being conveyed with a small number of words. And I can take the egg and go about, and there's some sort of quest that unfolds from that point. Now, not working with graphics means I can think about the semantics of this space without getting bogged down into sprites or animations or things like that. That are just very, very hard to do. But of course, it also means I have to deal with text. And natural language processing is also not an easy thing to deal with. So in generating text, I really do have to think really hard about the semantics, and semantics are expectation. So what should I expect when I climb a tree? Do I actually see text that meets my expectations of how the world should change, right? It's easy to say dimly lit and forest and trees go together. We would not expect to see a toilet in a tree, for example. So if I had the word toilet there, we would be very, very surprised. So again, coming back to this notion of evaluation, it's very clear when the AI doesn't understand what it's doing, right? Because things stop making sense and it responds to me and my actions in nonsensible ways. So this is a very good way of knowing exactly what my AI does and does not know. It's either confusing the heck out of the player, or it seems like it's playing along with the player. Okay, so now we've got these game worlds, and they're in text. And hopefully I've convinced you that text is an interesting way of dealing with the expectation aspect of computational creativity. So let's talk a little bit about how we might go about generating a text game, a textual world that a player can type into and move around and experience and manipulate. So we want to generate text games. I'm going to break this into two problems. I'm going to break it into the world, so what it is that we see in the world and how we can move around the world. And I'm also going to layer onto that quest. So things happening in the world that aren't purely driven by the player themselves. And in terms of computational creativity, I'm focusing on two things. I'm focusing on expectation and intentionality. Expectation gets operationalized as common sense and thematic knowledge. So in other words, do I produce words, sequences of words that tap into how we understand the world should work, and thematic knowledge about how stories unfold. And the intentionality is about coherence, making sure that as the player interacts with this world, things happen in a sensible sequence, a sensible progression. So quests unfold in a way that we would expect quests to unfold. And the goal is to generate as much of this as possible and to not rely on human designers. So let's talk about game worlds first. How do we build a game world in text? Well, we don't have to worry about graphics, but we do have to worry about words. And I'm going to cheat a little bit. Okay, so I'm going to make this problem a little bit easier. What I'm actually going to do is I'm going to take an existing book, and I'm going to try to reconstruct that book as a interactive environment. So when we read Sherlock Holmes books, right, there's a very linear sequence. Conan Doyle takes us through the world in a very specific order. But what if I wanted to go into the world of the Red-Headed League here and be able to walk around and talk to characters in my own particular way? right? I need to then make a linear experience into a nonlinear experience. And that's what we're going to try to do here. Turns out stories are actually a great source of semantic and thematic knowledge. So in a lot of my work, we read and try to learn information from stories because stories just contain a lot of common sense knowledge about how people respond to circumstances and what you tend to see in different environments, as well as thematic knowledge. So, what happens in a murder mystery, what happens in a fairy tale, so on and so forth. And what we're going to do is we're going to extract this knowledge. We're going to learn from these books, and we're going to try to build complex worlds, and they're going to be represented as something called a knowledge graph. That's not particularly important. It's basically a way of organizing facts about the world. And there's a little example here if you really want to pause the video and look at it. But to not spend too much time on here, world generation, we're going to first try to learn as much as we can about a particular world from reading a linear experience, building it into a non-linear knowledge structure. And then we don't want to interact with graphs. So we eventually have to turn that back into text in an interactive fashion. And, you can dig into the details of our work in other ways, but basically this is what's going to happen when you turn a book into an interactive experience. It's going to look like a text adventure game. You have a location, you can read what is going on, you get some information about exits and things that you see. You get to type in something, so I can examine this character called John Clay, who I've been told was here. It tells me some information about this character. Seems somewhat reasonable. I could type in other things. All right, done on this in the vault. Let's go to Baker Street. Here's what Baker Street looks like, and we get more text that gets generated. Okay, and so this is maybe something that never happened in the original book, right? So maybe we never did the exact sequence of looking at Clay and then going to Baker Street, for example. But the player is able to interact with the world, and the world seems to make sense and change the way we'd expect it to change. Okay, I think it's a little bit even more interesting to look over at the quest side. So I'm going to spend a little bit more time talking about quests, because quests are about doing. It's what actually happens in the game to make progress in the game. We don't just want to wander around a Sherlock Holmes world. Well, actually, maybe we do. It's actually kind of fun. But actually, we want the world to change in response to what we're doing in interesting story-like ways. So given a world, what should the player do? And this is very much about semantic coherence, right? We don't want those actions to be nonsensical, to be unrelated to each other. Things happen that cause other things to happen, that cause other things to happen. So how do we achieve this coherence? And so what we're going to do is we're going to basically say, I'm going to take two things that I think should happen in this story, a beginning and an end. And what I want the AI system to do is figure out all the stuff that should happen in between. So here's an example, right? I want a husband character to fare for his life. And then at the end of the quest, he's going to scale the wall. What has to happen in between? And how do we know that those things are actually going to make sense when the player tries to do them? Because if they don't make sense, the player is not going to be able to get to the final act in this play, right? And where does this information come from? How do we get it? I'm not going to hard code the quest. I want to learn the quest itself. So we're going to turn to common sense reasoning, right? So what we're basically saying is if we want this story to make sense, we have to tap into what people know about the real world and bring that real world knowledge into our game world. So given a situation, X, whatever happens to be, we need to know things like what characters tend to want to do when they experience X. We need to know what it was likely for them to have been true about the world before X became a relevant situation. So we need all this knowledge, we need to bring it all in, and then we need to start manipulating it into causal relationships. Let's not worry too much about this, but it's basically the notion that certain things cause other things to happen, which cause other things to happen, so on and so forth. So let's kind of dig into this and kind of see how we might do this. First of all, I need common sense knowledge. How do we even get common sense knowledge into our computer? Well, for that, I'm going to, again, look out into the real world. I'm going to realize that other people have really actually kind of solved this problem for me. Right, so other people have put together common sense data sets and common sense natural language processing systems. They tell us information about the world, like when a person fears for their life, they might want to get away. They might want to be safe. If a person scales the wall, they might have needed to be at the wall. These sorts of facts can be achieved in lots of common sense corpora. And not to spend too much time and kind of dig down, I realize we had some technical delays here. We're basically going to try to create a space of all possible things that the player might want to do by looking at what characters might want to do and how those wants chain to other wants. We're also going to look at the back side of the story and say, well, how might we get to these things? What had to have been true to get to the wall? They might have had to have been at the wall. To be at the wall, they have to walk to the wall. They have to get up to the wall. And what we're doing is we're taking all this common sense knowledge and we're putting it out down here and saying, this is the semantic space we have to work with. Now what we have to do is we have to find the linkages between all these different actions that might happen in our quest, and then find a particular path. And I won't get into the details of how we're going to find this particular path. But at the end of the day, what we're doing is this intentional search through all the things that we know we can talk about because it's going to link up with our human common sense knowledge about how worlds work to find one that meets all the requirements for questing in our story. And at the end, we haven't linked this up with the computer games yet, but these are the sorts of quests that you get here. So one is in this Sherlock Holmes situation, and another is in a more kind of fairy tale sort of situation. And I wish I could kind of let you kind of peruse through these things. They're not all perfect, but more or less you see that there's thematic things that are happening, and the things that you do expect to happen do seem to happen more or less in the order that we want them to happen. So, you know, this is not a technical talk. I don't want to get too much into the details, but let me kind of step back and say, let me kind of, kind of reflect on some of the things that we did talk about. These text adventure games, for me, have been very good ways of dealing with creativity because it allows us to think about expectation and intentionality, two parts of computational creativity that are often overlooked. So expectation, requiring creative agents to understand the world in the same way the human audience does, because if we're producing things that the humans are going to understand, well, how do we figure out, how do we know what the human understands? And then how do we manipulate that? So intentionality is taking the things that we think the human is going to understand and putting them in different combinations until they seem to work for the goals that we want to achieve. I also like to think about my own systems. I like to reflect on saying, well, is this actually creative? If it's creative, how do we know? Can I pinpoint where creativity is happening in my system? And I think this is an excellent exercise to think about any sort of artificial intelligence and what it's producing. Where is the specialness happening? Where's the special sauce? In some cases, the special sauce is in error, right? Sometimes our systems just make mistake when doing machine learning. And the things that we get out are unexpected to us because they learned the wrong thing or they didn't learn the thing completely. This is sometimes very good because this creates novelty. It's a good way of creating novelty. Another good way of creating novelty is randomness, right? So sometimes our algorithms have to choose and they make choices random. So we often get aspects of creativity come through sampling, they come through error, but also they come through planning to say sometimes the choices I actually have to make a trade-off. And the algorithm is intentionally making a trade-off between two things because one of the things it thinks is going to allow the human to respond in a more appropriate way or see something that is going to be something that they understand how to manipulate. And so these are all different places we can point to and say, I'm getting a little bit of creativity from error. I'm getting a little bit of creativity because sometimes I'm making random sampling choices. And I'm getting a little bit of creativity because I'm thinking and making trade-offs between two complicated, semantic constructs and so on and so forth. So, and then I think this is applicable not just to computational creativity, but to all AI systems to say, what is really causing the thing to work? Is it the things that you expect to work? Or is it something that you're not thinking about? So this is a great example of things to do. And I want to just kind of end with a couple things that Microsoft has asked me to kind of leave you with. In terms of talking about computational creativity and talking about these text adventure games, I think there's really kind of an interesting opportunity to look at types of games that are largely unexplored in terms of language games. So we play language games with other people all the time, but we don't do it through computers. And what we have out in the world is not just computers, but we have voice assistants. We have Siris and Alexas and Bixbys and Cortanas out there. Why aren't we playing games with them and through them? Why aren't we doing more role-playing? Role-playing is actually one of the most common gaming activities between humans, but it's not something that we do with computer games. And while I haven't talked about this, there's also an interesting aspects with intelligent co-creation. So using agents to help humans create more complex worlds by having semantic understanding. And of course, we don't get all this for free. There's this one really big challenge, which is we really don't know fully what we need to build systems that we would consider truly to be computationally creative. Our understanding of this concept of creativity is still incomplete. I've given you some hints. These hints are kind of my opinion. I think they're valuable. They've been valuable in my research, but certainly we don't understand what it means. And that means our understanding of artificial intelligence in general is also incomplete. We're not done looking at new algorithms or developing new algorithms that can do interesting things and respond to humans in interesting ways. And so this is also an invitation to say, come and work with me, come and work in this exciting, fascinating world of computational intelligence and computational creativity, because we're going to just learn and discover so many great things. And those things are going to make our games better, and they're going to enrich human storytelling and enrich human experiences out in the virtual world and out in the real world as well. So thank you very much for going along with this ride with me. I apologize about the technical details. I understand we might be a little bit behind schedule because of that. I do hope that there is a chance to have some dialogue and questions. I definitely look forward to hearing what your thoughts are about the topics we've talked about today. So thank you very much.
Wow, thank you all so much for the wonderful questions. And thank you so much, Mark, for your insights and discussion. This was an insane talk. I really enjoyed all about it. I really enjoyed it. And so I guess I can start with questions at this point. So let's go to our live Q&A. So first up, I'd like to talk a little bit about your ending challenge there and ask a question about how computational creativity is a subject that has many different stakeholders from many different backgrounds and fields. And in your talk, you mentioned some really interesting technical challenges and how we might get around them to enable this wonderful experience. But how can non-academics or people who aren't traditionally in the technical research space get involved with this fascinating work?
Well, I certainly don't think that computational creativity is only in the domain of people with PhDs in artificial intelligence. Hobbyist creators, I think, are the richest form of creativity out there. They do more in terms of indie games and even board game design, card game design. There's lots of things you can do in the creative AI space that don't even involve computers, right? And I think the question here is like, one of the things I'm trying to do is I'm trying to break down creativity and saying, if we're going to make interesting progress in computational creativity, we can do it about thinking, about psychology, right? We can think about human reaction. And every time we go out and build a board game or a computer game, we are doing these trade-offs, right? The things can't be random, but things have to be interesting, right? Things have to make sense. Things have to progress, but also things are a bit data-driven, right? I mean, so what I'm trying to do is I'm just trying to lay out kind of some of the different things that have to be balanced and thought about. And I think there's lots of opportunity to be a big thinker in the abstract, but also a tinkerer to actually operationalize and put some of these ideas into practice. And then, the PhDs can go off and build their algorithms, right, and try to do that other stuff as well. But I think this is the sort of thing that everyone can be involved in and be contributors here. And we know so little about this that everyone can have an opportunity to push our understanding forward.
Yeah, I love that, especially given the amount of creative content generated by everyone who's not a PhD. So another question was about more recent breakthroughs about these large language models in text generation, and you have some games like AI Dungeon that make use of that. What's your take on that line of development? And maybe are there other aspects of your work which covers things like themes or archetypes or other values in storytelling that maybe these systems don't cover?
Yeah, no, great. Like so much progress in neural networks and large-scale neural networks, both in the visual domains and the language domains. So GPT-3 and GPT-2, even all these sorts of things. They've come a long way in terms of like pre-compiling large models that have clearly some semantic understanding. So if you put in text, you get text out that makes sense. But I also think that from from a practical perspective, they work very well. From a creativity standpoint, it's very easy to discover the limitations. So things that look really good until you kind of basically ask them to start telling stories or to make quests or to build out aspects of the world. And what we discover is that, in any individual word that gets generated seems to make sense in the context, but goal-drivenness is something that they're not able to achieve. They don't understand kind of what a world means, right? They don't necessarily understand fully common sense and how it's going to interact with the words that come out of these things. So one of the things that I have been very interested in is the fact that on the surface, these big language models are so impressive and so great for so many things until you try creative aspects. And then we see clearly our models, our theories of artificial intelligence, we haven't tackled everything that needs to be tackled there. And we wouldn't have known about it until we tried to really look at things from a creativity and generation standpoint. Expectation isn't always there. Novelty definitely is. Intentionality definitely isn't there, right? So there's things missing in our algorithms. That's great, right? Now we can go research what to put into our algorithms to make them better.
That's amazing. I think there was another really popular question about essentially how far off is an automated story generator for video games from the market? And given that estimate, what would be some of the challenges that if you were working on them, you would sort of focus on?
Yeah, no, that's a great question. It kind of depends on what you want and what you need in computer games. Like computer games are great because they're practical applications, right? If you want to deploy something, like they have to work, right? So this is fascinating trade-off between what algorithms can do and what actually is going to succeed in a computer game. I think we've been able to do simple quests in very constrained environments for the last 10 or 15 years even, but maybe that's not better than what a human could do with putting a bunch of designers to just make a big library, right? So what we want is like more personalization. Stories, I think stories are coherent for about a paragraph, maybe 2 paragraphs worth of content before our models tend to kind of fall apart, right? So there's a lot that we don't understand about keeping semantic coherence for long periods of time, to refer back to things like great stories, like pop up old information in new ways, right? And achieve surprise and suspense and these really cognitively complicated phenomenon that humans have. So we don't model human emotions in stories, and we don't understand how to create emotions, and we don't understand how to keep these systems kind of coherent for long periods of time. So short scale quests, small quests, I think we could probably do it now. Long term, like Dungeons & Dragons campaign, 50 hours worth of story, it's going to be a while before we get to get there. There's problems that are core fundamental research problems that we still haven't even touched the surface on there.
Absolutely. I do think that we have unfortunately run out of time. There are so many questions left, and I'd love to keep you here for another hour. But I really do want to thank you once again for your wonderful, talk and the insights and the discussion. And also thank you so much to the audience for your wonderful questions. Thank you, everyone. We will continue with our parallel sessions at 25 past the hour. And there's the agenda up on your screen, at least the links for the next 2 tracks. So please join us there. Thank you all once again.